Hello AP Calculus students. This video on integration is going to cover the technique of integration by parts. So integration by parts is a lot like U substitution. However, there are two different variables we work with. So one is U and one is V. And what we want to do is assign all the values within the integrand and the differential in U and dV. So in this case, we're going to go ahead and select x for the u, and then the dv will be the cosine of x dx. One technique, or I should say one acronym that you could use to determine what u is, so if you're assigning the u, would be LIPIT. And, LIPIT stands for logs, inverse, power, exponential, and then trig. And so that's the order in which you would want to assign the u value. So for example, we have a power function, we have x, and we have a trig function, we have cosine. And so because the p comes before the t in LIPIT, we want to give the u value x rather than cosine x. So this is a technique that can help. It's not a guarantee, obviously. All right, the next step is that we want to find the du. So du is going to be just simply dx. And then we find v, which is the antiderivative of cosine, and that's going to be sine of x. And we'll take care of the plus c a little bit later. Okay, the integration by parts formula starts with u dv, so that's what we have done already, is that we've assigned everything u and dv. And our equation becomes uv minus the integral of v du. And so if we put all of these pieces together, in this case we have x cosine x dx. That is going to give us u, which is x, and v, which is sine of x, minus the integral of v, which is sine of x, and then du, which is just dx. And so we do need to go ahead and find the antiderivative again. So what we're going to do is just keep the x sine of x, and then the antiderivative of sine is negative cosine. So the minus a negative will become a positive cosine of x, and then we add our c, and we are all done.